Welcome to part 2 of my CNC build. In this video I want to show you guys how I made the Y and X axis. But first let's look at some of the parts that go into the assembly. I want to go over some of the design features of my parts because it's easy for me. I've been designing and working on this machine for a couple of years now, and it's very easy for me to know how everything goes together, and I'll do my best to explain it to you guys so that maybe you can understand my thought process behind some of the parts. These parts, that you can see here, are parts that go into the Y-axis assembly and also partly join up with the X-axis in some way. This is the left side Y-axis carriage block. It houses two linear rail carriages, and also the ball screw is mounted, or the ball nut actually, but yeah, it's mounted into the block itself. The reason for this cutout here is because it mates up with this. This is a spacer block for the Y-axis ball screw assembly, I guess. It houses a FK12 block here, the fixed side of the ball screw mount. It houses a coupler in between the ball screw and the servo motor that goes here. And this is made, the cutout here is made because if I am able to like house this block inside the cutout like this, that means that I can get 17 or this block's depth more travel out of the machine without having to compromise in making the machine bigger. Like, of course I could mount it like this and then the servo motor and then everything builds on further away here, but that would mean that the machine is bigger. So this is the reasoning behind this is basically just to get the machine as compact as possible with the amount of travel that I want it to have. This block in turn is mounted onto this. This is an end plate for the back of the Y-axis. The block mounts like this, sort of like that. And it has a cutout back here for a servo motor. And it's mounted on the Granite side. On the other end of the Y-axis, this plate holds the FF12 block, or floating block for mounting the ball screw. It's also bolted into the Granite sides. Both of the blocks have a small tapped hole here. This is actually not tapped yet, but it's going to be. And this hole acts, or into this I'm going to screw a screw, and that screw is going to act as the part that the inductive sensors are sensing when the machine comes to the end of its travel. Because aluminium is kind of funky with some of the sensors, I opted to just put a steel screw in and use that as a sensing surface instead. So moving on to these parts. This again is just a spacer block for, this one is for the X-axis ball screw. And this is the side plate that mounts on the side of the carriage. It has a notch cut out of it here to help me align it better to this part, like that. It's kind of hard, but like that. so that I know that these two are square to each other. It also has a notch, there you go, a notch here for mounting the, or for aligning the granite side, the boom, sorry, the granite boom, and make it as square as possible. Of course I need to check it against the reference, being the surface plate in the bottom, but this should help a lot with alignment. On the rear end of this there is a cutout for the servo mount. It is time to assemble the X-axis linear rails. And as you can see here, I have prepared the granite boom quite a lot. I am pretty sick of drilling into granite and putting inserts into it. So I thought maybe you guys don't want to see that. If you want to, you can go back into the previous video and see how I did it there. It's the exact same things, just many times over. For the rails, I'm going to start with the bottom rail here. Make sure that the bottom rail is level to the surface plate. When that one is mounted, I'm going to secure the second rail. So I've finally managed to get this rail within 5 microns. Seeing as this surface plate is actually certified for 5 micron deviation, I think it's acceptable to say that the rail is parallel within 5. What I'm gonna do now is I'm gonna tighten the bolts to the torque specification of the linear rail, and then I'm gonna sweep it once more and mount the second rail. Do the same thing over again, and after that I'll come back to you. Okay, the rails are finally mounted and aligned, and just a few pointers to anyone who would like to do this themselves at any time. The rails, I found it was easiest to work from one end to the other, and then as I worked I torqued down the screws a bit more as I went past them, because when you make adjustments on the rail moves in the other end. So you kind of, if you need to go up here, let's say, then you will try and push it up a bit, and then it will most likely go down further along the line. So as I work my way, I will torque down on the screws, making it a bit less probable to move. You still need to go back and kind of try to iron out some of the high or low spots, but it takes a lot of time to do this on a micron level with a dial indicator like this one, and also because I'm not experienced enough, frankly. I suspect a professional can do this a lot faster than I could. But it's done. They're securely mounted, and I'm gonna bring out a few parts that go into the X-axis assembly, and I'll talk them over real quick, the same way I did with the Y-axis. So these are the parts that go into the X-axis. Obviously there's 2 more blocks, linear carriages, but these 2 kind of serves the same purpose as the blocks for the Y-axis, especially this block. This holds 2 of the linear carriages and also mounts the ball screw or ball nut. This is also, I'm not sure if you can see it, there's a slot here, or there will be a slot here when there's a plate that goes on top here. And this is going to house one of the protective sheet metal parts that's meant to protect the ball screw and linear rails from ships, to some extent at least. So I'm gonna mount these two, and then I'm going to have to push in the ball screw, I think. We'll see. I need to do some tinkering about exactly in which order to mount all this stuff, and then I'll try and give you guys a good up close, and you can kind of see how these parts interact with each other. Okay, so as you can see, the lower block here is mounted. I'm going to need to align this with the table, so this surface here is going to be aligned with the table to be parallel with the table, basically. And this is important because otherwise I risk carrying errors from multiple parts with me as I build, because there are quite a few parts that go onto each other from this stage until I reach the spindle itself. So I want this to be perfect and as close to zero as possible, and then I can add the next part and continue in that manner until everything is done. After this one is lined in, I'm gonna line in the ball screw, so that the ball screw as well is parallel to the path or travel of this block. The block is mounted, the top block here. It is indicated in, and it's very parallel to the surface plate. And just as a check, I use this machinist square to try and see that the surface here is parallel to this surface in this direction, in the Y plane in this case. Because if these two aren't parallel to each other, when I mount a plate here, the plate is gonna nod or shin up, depending on if this one is higher or lower than the other. And in this case, I have realized that the top block here is actually protruding more than the bottom block. And that would give me like a nod on the plate itself, and I don't really want that. So I'm gonna take this block off and use a whetstone to get it to spec with this block, basically. Now I have considered the implication that the granite itself may actually be nodding as well, because in theory, like the granite could be slightly tilted forward like this on the top, which would cause a difference between these two surfaces. However, because I can't really do anything about the granite, and also because when I move these two blocks along the rail length, I come up with the same difference between them across the whole length, which means that tells me that if there is a nod in the granite, the nod is equal along the whole length, which means that I can safely remove material from this to make these like 90 degrees to the table, and then I wouldn't be at risk of, for instance, pushing it too much in one end and too little in another. So I'm going to remove this and get sanding, basically getting down to spec, and then we'll come back. The x-axis and y-axis are finally complete, and at this stage of the build I can also show you the covers I was trying to explain earlier. These sheet metal covers, they cover up the rails and ball screw of the machine so that ships will have a harder time to get in. Obviously there are still some slots and places where ships can get in, but hopefully they will protect against the majority of them. If you have any comments or questions, please feel free and write them below. And if you managed to stay awake through all of this video, thank you for watching, and I'll see you in the next video.